Cool. So this is the Twitter Bots with Replit session, an interdisciplinary approach to computer science education. My name is Jenny, and today I'm going to be presenting with my really good friend David, and I think we're going to go ahead and get started. Cool. So next slide, please. Thank you. Lena, Brittany, David, and the rest of the EdFest team invited us to share a computer science project that we designed for undergrad students at Stanford. And so if you could go ahead and click, David, what you're going to see on the screen are tweets from a wide range of people. I don't know if you can see them, but we have bad comedians, we have a Shakespearean poet, we have a Among Us player, a foreign language speaker, Yoda himself. If you look in the middle left, you see a tweet from a dog who says, "Where is my owner's left sock?" And then in the bottom right, you see a wine taster who says, "I think this Burgundy Pinot Noir suggests hints of raspberry." And you might have already guessed this from the title, but these tweets are all actually from Twitter bots that our students built to simulate somebody else's language. And so the students designed their own grammar using the linguistic knowledge that we had talked about and learned in our class. And then they also built their own Twitter bots that would automatically tweet phrases from the grammars that they built. And so we wanted to share a bit about this assignment as a little bit of a case study. And at the end, we'll reflect on what we learned from this experience of designing this interdisciplinary project on Replit. Next slide, please. So by the end of the session, we're hoping that you will have the tools and the confidence to make your own Twitter bots on Replit with even students as young as middle or high school. So we did this with undergrads, but we really think this is a project that's accessible to all ages. And you'll see an example of a tweet there. Next slide. We'll present the step-by-step framework that we use to create our interdisciplinary project, and hopefully it might be useful to you as well. And the next slide. Because our project happens to be about language and computation, you'll also learn some fun tidbits about how we can think about human language as a computational phenomenon as well. Cool. So this is our breakdown for the 30-minute workshop. We're going to start with just some background, some context to get you oriented with who we are, what the class was, what the students were in our class. And then we're going to walk you through a 20-minute whirlwind version of the assignment that we had our students do. And so there are two main parts. One, we're going to walk through building a language. And then two, we're going to walk through how to tweet phrases from that language. And we're going to try to make this part as interactive as possible. And then finally, we'll kind of reflect on what we learned through that process. So we'll start with some background. Next slide, please. Cool. So my name is Jenny, and I recently just graduated with a master's in computer science from Stanford. I'm really interested in designing technologies for learning, and I actually was a former intern at Replit, so I'm really excited to be part of the Replit community again. I'm currently teaching computer science at Stanford this summer, and I'm really excited about making computer science personally meaningful, equitable, and inclusive for all learners. And I'll pass it on to my friend David.
Thanks, Jenny. Really excited to be here and walk through this project with all of you. My name is David. I recently graduated last year with a master's degree in symbolic systems from Stanford, and I focused primarily on topics in educational neuroscience. Previously, I've worked as an associate product manager at Fortune, where I led the launch of Fortune's newest internal startup called Fortune Education in partnership with 2U. And most recently, I'm a part of Day One's inaugural EdTech Accelerator program for EdTech entrepreneurs. So Jenny and I first crossed, let's go back there. Jenny and I first crossed paths at Stanford when we co-taught SimSys 1, the introductory course for symbolic systems major. And today, as Jenny mentioned, we're going to be walking you through a fun interdisciplinary and interactive project using Twitter bots and Replit that Jenny and I co-designed for this course. So at this point, you might be wondering, what the heck is symbolic systems and what does it have to do with creating interdisciplinary CS projects? So this is a question that Jenny and I get a lot, since symbolic systems is a major that's completely unique to Stanford. So just for a bit of really quick overview, symbolic systems is an interdisciplinary major that exposes students to coursework across computer science, psychology, statistics, and philosophy in order to equip them with the background and scientific tools that are needed to deeply explore the relationship between minds and machines. And so some questions that the major introduces students to are questions like, what is a mind? How does it work? How do we as humans think and learn? How can we leverage technology to better understand or amplify how we think and learn? and is it possible to computationally model a mind? So at its core, symbolic systems really introduces students to the value of thinking about hard problems through the lenses of many different disciplines simultaneously. We also have some pretty cool alumni that have built products that you might be familiar with, like LinkedIn, Facebook, and Yahoo. So Jenny and I really loved being in the symbolic systems major, but a key challenge that we ran into as part of the teaching team for the introductory major was, how do you design a course that spans so many different disciplines that is both accessible and challenging from students from all backgrounds? So this was especially challenging at Stanford, where on the one hand, you have students that have been coding since they were 8, but maybe have never taken a philosophy course in their life, while a student sitting literally next to them may have never written a single line of code, but is a published author in philosophy, which was actually the case in my class. So the solution that we came up with was a course designed around hands-on, beginner-friendly, interdisciplinary projects and modules that hit on key themes and topics of the major. And we used helpful tools like Replit in designing these projects. So we redesigned the new course to span across 4 larger modules, each of which culminated in an interdisciplinary project that can be completed by students of really any background. And in today's session, we're going to walk you through the first project that we designed, which helped students understand natural language in the context of minds and machines. And before we continue, just introducing the interactive elements to this workshop, please navigate to the link to the assignments. And I think Jenny will be posting it in the chat. There we go. Within this document on Notion, you'll have access to everything you need to be able to follow along with today's session, but also to be able to build your own Twitter bots with your students in the future. So before we can build our own Twitter bots, which Jenny will be walking us through in just a short while, we need to know how to build a language so that we can have something that our bot can automate. So without further ado, let's build a language. To build a language, we have to define a set of rules called a grammar. One thing that's notable about grammars is that they have very computational properties like decomposition, abstraction, and recursion. In the assignment we had students work with what is known as a context-free grammar, and the materials link that we provided will go into much more detail on what exactly a context-free grammar is, but for the purposes of this workshop, we'll only need to know that a context-free grammar can be defined by a set of production rules where you can specify certain symbols on the left-hand side of an equation to be replaced by additional symbols or words, tokens in this context on the right. So here you'll see we have a set of 4 production rules. One such production rule is S can be replaced by sub plus V plus object. So, clearly this is sentence can be replaced by a subject plus a verb plus an object. And then we can use these production rules in concert. So these 4 production rules here to model sentences. So you'll see on the syntax tree on the right-hand side of this slide, these 4 production rules can actually resolve to create sentences like, I created this. And we're going to be walking through additional production rules in a very hands-on way in just a minute. But one cool fun fact to note before we move on is that all human languages, in fact, can be modeled or represented as a set of production rules. So what we just did is walk through just a little bit of an introduction about languages and grammar. And now that we have this kind of background, we're going to explore the topic further with the use of a helpful tool called the Nearly Parser Playground. But in building a language, we need, someone to model. So we thought it'd be fun to build a language interactively for a student who always has an excuse for not turning in their homework on time. So before we move on, let's go ahead and drop in the chat. What are some excuses that a student might give for not turning in their assignment on time? My dog ate my homework, Jenny. Nice. Any others? My dog ate my charging cable. Very appropriate for Zoom times. My grandma exploded.
I love that one.
That's the best one I've so far.
We should add that to our grammar.
We should absolutely add that to our grammar. All right, these are great. We are well primed to move on to the interactive portion of this assignment. So And moving on to the interactive portion, we're going to be playing around with constructing some grammars on the Amarelli Neri Parser Playground. So at this point, I'd like you all to navigate to this playground, and as well, while you're also navigating to this playground, please follow along with the assignment as well. And what I'm going to do is actually stop sharing my screen just for a minute and walk through these links as well. So let me reshare my second window up here. Perfect. And you should be seeing this screen. Great. So welcome to the Neri Parser Playground. This is a tool that will help us use production rules in order to model a language. So if we navigate back to the assignment materials, the materials for this workshop link, we will be able to see these initial production rules that we're going to use as kind of starter code for this exercise. So if everyone can just go ahead and copy the production rules from this portion, go back to the Neri Parser Playground and just paste it in. And once you do so, if you notice in the bottom right-hand corner, we'll be able to click the Generate button to create our sentences. So this is a playground that we had students play around with in order to really understand how production rules work, how robust some sentences can get, and it kind of almost functions like Mad Libs. But now what I want to show you, or actually I want to take some suggestions that we have to make our sentences a little bit more elaborate. As we see here, these are very simple sentences. Excuse me, professor, I forgot my homework. Excuse me, professor, my brother lost my paper. And I know we already had a lot more interesting examples already posted in the chat. So for the first, let's add a subject. Can anybody think of another subject besides I, my sister, or my brother? All right.
Let's do grandma. Oh, and dad.
My dad. Love that. My grandma. I like that as well. Oops. Great. And now let's add in an extra action. So call them out. Barked. Okay. Interesting. Very cool.
Can we add exploded as well?
I liked, yeah, exploded was a great one. All right, and for the sake of time, let's leave this as it is and go ahead and generate some of our other sentences. So now we have a little bit more rich language to work with. Excuse me, professor, my grandma forgot my homework. Excuse me, professor, my brother lost my paper. Let's see if we can get exploded in here before we move on. My brother barked my homework. That's interesting. I don't know if we're going to get to explode. There we go. Excuse me, professor, I exploded my homework. So let me delete these really quick. Now what I want you to do is just kind of play around yourself with this Neri Parser Playground, and a couple of things you need to know is let's just add some things across subject, action, and object. And to do so, you're going to want to create these pipes, which are kind of or statements. And then in quotes, you can add anything you want. So without further ado, we're going to give you just a minute or two to come up with your own unique sentences. And once you generate them, go ahead and paste them into the chat. All right, so I'll stop sharing my screen for a second. There we go. All right. And yes, Miguel, this will be available, I believe. All right.
Feel free to ask any questions as well.
Yeah, if anybody's having any problems.
Mm-hmm.
Very cool. Thanks, David. All right. Mm-hmm. And if anybody has any problems, we do have the materials link that you'll notice under teaching materials will go into a lot more detail in case you have any issues with this, the setup. So no worries if it's a little bit tricky at first. There we
Awesome.
go. Very cool.
Oh, no.
Oh, no. So that's a great excuse. Hey, Mom, my brother stole my wife. That is an excuse for not turning in your homework on time. Fair.
Super fair. Excuse me, professor, my computer crashed my paper. That's great.
Love it. Very cool. All right, go ahead and keep posting these in the chat as we move along. So, you know, what this kind of shows us is that our grammar can be really extended and made significantly more complex in modeling a language. So very cool stuff to kind of compose. There we go. Thanks, David. And one additional element that you can add into your grammar construction is elements of recursion. So you'll notice here on this slide in the excuse production rule, it actually calls excuse again. So that is an element in case you're teaching recursion to your students now that can add, you know, a lot more richness to your grammar. And so from here, let's go ahead and move on. Hopefully you all enjoyed that.
Great. Cool. So we just finished exploring the topic by asking students to design their own grammar. And really the next part is about further modeling that topic with code. And so when we say topic modeling, what we mean here is really using code to build something that simulates or models the phenomenon we care about. And so in our case, we wanted to use code to model language production. And so we asked students to program a Twitter bot that would produce phrases automatically from the grammar they just designed. And it's really important at this step that you don't add code for the sake of adding code to an assignment, but really finding a way to integrate computer science to actually deepen their understanding, to model the topic in a real and authentic way. And so hopefully you think this Twitter bot is one way to do that. So we actually used Replit for this portion of the assignment. And there are a couple steps that we're going to gloss over today about setting up your Twitter account. It's completely free and it's very easy. It takes maybe 10 minutes max, but you know, for your reference, all of the instructions step by step are here, and it's completely beginner friendly. We had students who didn't know how to code before who were able to build a Twitter bot from 0 to 100. And then we also used a Replit template so that students who did know enough code to tinker around with it were welcome to. The students who didn't know how to code yet had something that they could just build off of. If we hadn't used Replit, we probably would have spent a ton of time with setup and distributing the code, but using Replit made it much simpler. So again, the step-by-step are on the that tiny URL, but I will show you kind of just a whirlwind tour of what it looks like. So first I created my own Twitter account called @EdFestBot, and then I signed up for their developer access. This is what the developer portal looks like. And once you create your own project, I named it EdFest Grammar Bot, and then I have access to these keys and tokens, which will help me hook up this Twitter account to my code. And so this is really just a matter of copy pasting the right keys and secrets and tokens. And then you'll see on Replit, I made this template that all students are able to use to generate their own Twitter bot. And so you'll see actually 243 students have already created a Twitter bot using this template. And these are all students from our class. And really, if you wanted to make one, or if your students wanted to, all you would need to do is fork this template. Then you get your own version of the code. And then you'll have to go to the secrets tab and add 4 secrets. And these are things like your API key that you're going to copy paste from the Twitter portal that I just showed you. I'm not going to do it right now, but it is in the instructions. And then we have to find a way to get the code in this Twitter bot to actually tweet phrases from our grammar. And so to do that, we actually download the grammar as a JavaScript file down here from the Parser Playground. And then you can upload it here. And our code is looking for a file called grammar.js. So this is the grammar that represents the student who always makes excuses about their homework. And really, once you have that in here, again, if you know JavaScript, you're welcome to make edits here, change how often it tweets, change exactly what it tweets. But if you just click run, what you'll get is a fully functional live Twitter bot. And so I pressed run on this just a couple minutes ago, and you'll see if I refresh the page. 58 seconds ago, we had, excuse me, professor, my computer destroyed the take-home test. Excuse me, professor, my dog misplaced the take-home test. So it's generating random phrases from the grammar that we had just built. Cool. And so that's just a little quick tour of how we got a Twitter bot live tweeting from Replit. And I do want to show off some student work now. So in the past year, we had over 200 Twitter bots made, and students were really, really creative. So on the left here, you can see the first one is a student I had who made a Twitter bot to simulate some of her favorite phrases that her grandma would speak in Navajo, the traditional Native American language. And then in the bottom, you see a bot that simulates Singlish, which is a very specific Creole language that's used in Singapore and really important as a part of their cultural identity. And so we saw many, many instances of personally meaningful, culturally meaningful, and politically meaningful grammars and bots that students were able to generate. Cool. So that's just a little bit about how we used code in Replit to model language production. In the Notion, you'll also see other examples of bots that students made, and so feel free to peruse those at your own time. I will now ask David to talk about how we ask students to really reflect and integrate on both the linguistics and the computer science portions of our assignment in the last part of our assignment.
Awesome. Thanks, Jenny. So yeah, after deeply diving into this topic, exploring it and modeling it, we asked students to take kind of a bird's eye view of the project in general and think about it in kind of like a philosophical point of view. So we're going to ask you all to kind of do the same thing. And we have a couple of food for thought questions that we'll take a poll on to engage in this way. So our first poll question is, if we created a Twitter bot with enough rules and tokens, and so those are the production rules and kind of the elements like my dog, etc., do you think we could have perfectly modeled a real person? And by that we mean, in other words, could the tweets that our Twitter bot produces be indistinguishable from the tweets of a real person? So let's go ahead and take a poll here. And
you might have to head over to the polls tab.
Yes.
In
the head over to the polls tab. And there's yes, maybe, and no. Let's see. Let's wait maybe 15 seconds. Okay. All right. I'm going to submit my response. Okay. Very, very interesting. So we have yes at, it's changed around on me. Yes at 26%, maybe at 26%, and no at 47%. So a little more than half of you think perhaps, maybe it is possible. Now 50. Okay, great. And then we have our next poll. If we could have perfectly modeled language, so if our Twitter bot, can be indistinguishable from a real person, do you think we would have in some way created the mind of that real person? All right, and this is the second one. You'll find it immediately below the last poll. So let's check answers here. Oh, this is actually really interesting. I would have thought that more people would have said no here than the first one. Okay, very cool. So if you did answer yes, you might be in line with someone, an early supporter of the Turing test, which kind of validates human-like AI as an expression of language. So if you were able to convince somebody that, via language that you're a real person, you passed the Turing test. So interesting tidbit there. And that was a fun poll. So next slide, Jenny. So in general, kind of to sum things up, we explored deeply a topic, and then we modeled that topic language in terms of programming a Twitter bot to produce phrases from that grammar. And this last step that we took was a way to kind of just take a bird's eye view of the topic that we introduce students to and reflect on the capabilities of our bots. And at this point, we'll move into kind of some reflections that we had about designing this project in general and some takeaways we hope that you might be left with as well. So our first reflection from designing this Twitter bot was that the steps involved could be abstracted to easily create other kinds of meaningful interdisciplinary projects. And in fact, we followed the steps that we followed in introducing this topic, exploring it in a hands-on way, modeling it through some kind of computational techniques or methods, and then philosophically reflecting on the topic. We also followed those steps in creating the remainder of the projects in the course, all of which the vast majority of students found really engaging and deeply enriching. And so we hope that you find this framework potentially useful in creating your own interdisciplinary projects. And on this slide, we've included a few examples of such projects that you might use as food for thought. And as a side note, if you do use this model for future assignments, we'd love to hear about it. All right, and I'll pass it over to Jenny.
Cool. And then from the student perspective, one thing that we really took away from designing this assignment was the value of personally meaningful projects. We really saw students bring their whole selves to the assignment and really make connections from their lived experiences, the language, the kind of environments they grew up in, to this really abstract field of linguistics and computer science. And we think that was really special, especially for students who maybe didn't see themselves in linguistics or computer science coming into this class. Second, we think that we really gave students the opportunity to build a real project with an authentic audience. So instead of having them write a paper or a program that nobody would see, it was a real Twitter bot that was tweeting out and live in the world. And because of these two things, we really believe that students learned better as a result. And many, many students came up to us after this class saying that this Twitter bot assignment was the most memorable part of Synthesis 1 for them. So just really quickly to wrap up, we hope that you took away a simple model for structuring interdisciplinary CS projects, and also that in the future, you also take advantage of tools like Replit to make these sort of real-world projects easier to distribute and remix. And finally, we really love this idea that personally meaningful projects help all students learn. So that's it for today. Thank you, David, for dropping in our links again. We'd love to answer any questions or just hear from you all about some interdisciplinary projects you're excited about. I know there's going to be a curriculum jam, so I'm actually really excited to see what comes out of that as well. Special thanks to Erica and the rest of the Synthesis 1 teaching team, and also to the EdFest team for inviting us to talk. Thanks, everybody.
Thank you.
Okay, so I see some questions.
Kurt, I love that.
Thanks, Kurt. Yeah, our contact information is at the bottom of the Notion, so please reach out. Would love to hear about it. Thanks, everybody.
Thank you.
Absolutely. PBL for the win.
PBL.
Cool.
And feel free to ask, if you have any questions. We'll stick around for a little bit to answer. And again, as Jenny noted, we have our contact information at the bottom of the assignment document.
Woohoo.
We should have had.
I want to go to the next session. Yeah.
I know, me too. Yeah.
You want to head out in maybe a minute or so, David?
Sounds good.
Sweet.
All right. Okay. I think we can probably jump at this point. All right. Cool. Thanks, everyone who's still.
Catch you later. Bye.